what is the conventional machining or the substrate to manufacturing, and what is the 3D printing manufacturing? The substrate to manufacturing and the 3D printing manufacturing, both you can see that in a substrate to manufacturing, we are going to remove the material from the machine, the component. Like raw material is given to you. From the raw material, we are going to remove the material in the form of grain or in the form of chip or continuous chip. But in case of additive manufacturing, we are going to add the material in the form of. Please don't talk in between. Someone is talking. Abdul, keep with your mouth. Okay. In additive manufacturing, we are going to add the material in the form of a layer. Okay. This is one thing I wanted to tell you. Now, the additive manufacturing, it is a chain process. In this conceptualization, a conceptualization of a CAD model, we are going to create the model of the thing, what we are going to do, and we are going to convert this into conventional STL format. Please don't talk. Abdul. Okay, conceptualization of model. That means whatever the model we have created, that model has to be in the 3D model, and it can be created in any equivalent CAD modeling softwares. Once after creating this, the second step is converting into STL format and transfer to the additive manufacturing machine in the STL format, and machine setup has to be done, and some of the supportive things at all it is creating, it has to be removed and cleaned, and it has to be taken for the post processing. These are the important steps involved. Please try to remember the steps involved in additive manufacturing. The steps involved in additive manufacturing is creating the 3D model of the component, converting this 3D model of the component into STL format, and transferring this into additive manufacturing machine, and then do the machining setup. That means, as I told you, the machining setup is the temperature required and the speed at which it has to be traversed, and what type of machining is required, and all these you can give. And before you get or load it for the additive manufacturing, we can expect what is the time it takes, what is the amount of time it required, and what is the feasible orientation of the component we can do. Okay, so it's simply by erratic method or by trial and error method, we cannot locate or orient the component. So, which is the best method by which it can able to do feasibly the layering? It has to be seen. Then, how many layers is required? In 1 mm, is required 20 layers, or 30 layers, or 40 layers, or 50 layers. So, all these layering also have to be decided by the person who is going to operate the machine. If you don't give, it will be taking its own optimized thickness. Okay, then once it has been created, so before it go for the machining, what it will do is, wherever it is required as to give the support, it will be creating the support itself. Supports and some of the burrs which are created or which have been formed while doing the machining, those unwanted things have to be taken out. Okay, this is what we have to do. Now, what are the applications of additive manufacturing? The main important applications of the additive manufacturing is the functional models. So in some of the kinematic linkages, so many linkages will be added together, and it will be very, very difficult to analyze by using the computer softwares or analyzing softwares. Equivalently, so many softwares are available. You can see that Additive software, automatic dynamic analysis of mechanical systems. It is specially meant for the mechanical linkages, the collision testing, and how it is performing, giving the output. Okay, and in some of the cases, it is very difficult to analyze them. Very newly created mechanisms. Then in that case, those cases, we can do the functional models. The functional models are those will be representing the actual model, actual what we are going to do, the linkages. And another one, next one is pattern for investment and vacuum casting. The investment casting and vacuum casting, therein you can see that both the dies or the three dies will be there, the cope and the top one cope and drag, and in between sometimes we'll be using the cheek also, and we are going to use the green molding sand, and in between this we are going to create the cavity, and this cavity has to be created by keeping the actual model. And to create the actual model, it will be taking a lot of time. What we are going to do is, we are going to do this model by using the additive manufacturing method. So whatever the model it is required, equivalently by means of a wax or by means of a plastic or by using the low cost materials, we can create this model in the 3D printer, and we can use this as a reference pattern to create a cavity in the mold, so that we can pour the metal and we can get the casted metal. And medical models, very sensitive models or sensitive application equipments will be there. Therein very, very sensitive things we need to create, and it is not conventional. That means we require to have only the testing purpose, 1 or 2 models we need to do. So that time, you know that it is very difficult in creating an manufacturing atmosphere in the automated devices. So that time all the planning how to be shut down, it will be taking a lot of time. So if you are going to buy the conventional method, these delicate jobs cannot be done by the workers. It is all totally depend on the workmanship. So in such cases, we can go for the additive manufacturing for the medical applications. And sometimes we are going to the odd models. Art models are those, some the decorative pieces and some artwork also can be done by using the additive manufacturing. And sometimes we are going to do a testing of prototype. We heard of it in a design process. In single design process, we are having the different stages. First stage is identification of the problem and defining the problem, and going for the synthesis of problem, and going for the analysis. Okay, and once you do the analysis, what happens? Once if it is ready, then we are going to have the prototype of it. Sometimes whatever the prototype you have generated by using the 3D model, if you are going to do the testing, one of the problem what happens is totally the accuracy of the output will be depend on the designer. What kind of input or sensitivity of input he is going to give. Based on that, the analysis solutions will be there. So in such cases, we cannot believe the solutions. Approximate solution around 70 to 80% we can believe the CAD model of analysis. In such cases, we are going to create the new model, okay, new model for the analysis. That is engineering analysis model. And rapid tooling. Okay, rapid tooling also can be done. New material development, any new material or composition you are going to do, that can be developed, and bimetallic parts also can be done. Or that means even instead of using one nozzle, you can use the multiple nozzles. Okay, the multiple nozzles will be having multiple materials. All these will be added together so that it will be creating the bimetallic part. And you can go for the remanufacturing, that is reverse engineering. The reverse engineering is one. There are so many softwares which are available. From the existing actual part, we can extract the model. That means we can have the probe systems or a digitizing board. On this, we are going to keep this model, and already we know that the probes can be moved onto this, and coordinates can be extracted, and automatically the 3D model of it will be generated. And this 3D model which have been generated can be converted into actual physical model by using the 3D manufacturing or the additive manufacturing process. That is remanufacturing or reverse engineering. And in some of the applications like the defense, aerospace, automobile and the biomedicals and some general engineering industries, these are all the very important applications. Kindly try to remember functional models we can create. The explanation for this is the synthesis of linkages we can do, and pattern for the investment and vacuum modeling casting. That means very one or two models which you need to do, and we require to go for a lot of machining or we require a lot of accuracy. In such cases, we can have the we can use the 3D printer for the model creation purpose. Okay.